In this video, we are going to learn about measures of electricity by considering an electrochemical cell. When metals form ions, they give away one or more electrons. Can you remember the charge on an electron? Pause the video and continue when you are ready. The correct answer is that electrons have a negative charge. When a metal gives away its electrons, they do so with a certain force. This force you measure in volts using a voltmeter. If you connect a strip of copper and a strip of zinc metal to a voltmeter in a solution of their ions and connect them by a salt bridge and a wire, you have made an electrochemical cell, also known as a battery, but technically a battery is a collection of cells connected together. The two metals connected in this way cause an electric current. This is because zinc is higher up in the electrochemical series than copper. This means that zinc can push away its electrons more strongly than copper can. As a result, electrons flow along the wire and through the voltmeter from the zinc to the copper. The flow of electrons is the electric current and is measured using an ammeter. Current is measured in amps. The more charges that pass a point in the wire at any given second, the higher the flow. Therefore, the higher the current. It is important that you remember that the electrons do not flow through the solution, only the wire. It's charged ions that move across the salt bridge. The voltmeter measures the force that pushes the electrons through the wire. Say that you replace the zinc metal for a metal that was higher in the electrochemical series, like magnesium. Can you predict what would happen? Pause the video and continue when you're ready. The correct answer is that magnesium would push its electrons away with a greater force towards the copper. This would cause a higher voltage reading on the voltmeter. Similarly, as a result of a greater force on these electrons, more charges would pass a point in a given second. This means that the current would be higher as well. Did you get it right? In summary, what have we learned? 1. Different combinations of metals connected in an electrochemical cell will produce different voltages. 2. The size of the voltage and the current is dependent on the metal's position in the electrochemical series. And 3. The further apart the metals are in the electrochemical series, the greater the size of the current and the voltages produced.